Okay, so hello everyone. My name is Łukasz Stanisławski and I work for Samsung Poland R&D. I would like to say a few words about the AT-SPI support in elementary. To some of you who are not familiar what this weird acronym is, this speech generally will be about the accessibility support in elementary applications. So at first I would like to make a quick introduction what AT-SPI is. As you can see, it expands to this, but the most important part is that it's only an interface. So in fact, it does not implement any accessibility features, but gives the APIs to make some external processes implement real accessibility features. So it's this whole concept for application not to provide the accessibility or for framework to provide accessibility features comes from the GNOME desktop, but their solution becomes so popular that it was adapted by the Linux Foundation. So if you can check it there. What is more, that this standard is also implemented in Qt, Gecko, or even in LibreOffice. And the best thing which describes this APS, it's that it should be toolkit neutral, but it's not. In fact, it isn't, because every accessibility clients, which are de facto providing accessibility features, were implemented in a GNOME environment, so they have, let's say, adjust to their solution. So, okay. To explain how it all works, there in the desktop environment, there are three main components. That first there is an accessibility bus, which is the separate dbus instance, and there are two kinds of buses connected to this daemon. First is the application itself, which acts like a servers, and they provide the APIs to control them, to receive, they also broadcast some signals about the changes of the UI. And on the other hand, there is accessibility clients, which are in fact the external processes which are implementing the accessibility features. The most common one is Orca screen reader. Okay, as I think mostly of us were at the previous AFL Developer Day, so colleagues of mine have presented this accessibility solutions made entirely by using implement this almost the same way like it was done in the GNOME. So this solution was presented, but it was not well received because all the dependencies. So I was asked to re-implement it to more LFL way. So we have wiped out all the GObject stuff, and generally the code is available in the elementary source tree under this whole interface AT-SPI. Okay, so now I would like to make some demonstration. Okay, so I have to. sorry. Yes,
Speech enabled. Backspace. Return. Entry.
okay, so
Scroll 3D frame. EVS map 3D push button.
so generally it works that way, that all the widget is exposed on the on this accessibility bus, and it's generally it's a separate dbus object. So when I, let's say, change input focus between the widgets, the accessibility implementation broadcast is on the accessibility bus, and then the Orca screen reader receives this, analyze it, and just read it to the end user. What is more interesting, that it doesn't just blindly read the text which is displayed, but Orca can also analyze the context in which the widget is appearing. So, for example,
application client / server frame message push button.
So, when we have changed the frame, the scroll between the containers, the Orca received the focus from the message button, but also analyzed that this new widget is enclosed in a new frame, and it also decides to read this frame to the user. Okay, so generally
frame, Boolean frame,
there are
check push button, return, boundaries frame, left alt, icon sized to checkbox checked, return, not checked.
the synthesizer is, but there are much more states, like
checked.
Check.
Icon not either, label only, checkbox not checked.
Okay.
Boundaries frame, bubble push button, label only, checkbox not, boundaries frame, bubble push button.
Okay, so
Boolean app 3D entry.
there is also
external frame, image range values frame.
the separate dbus.
Manual step slider 0.1.0, 2.0, 3.0. Always show slider 0.0.
Okay, so it also this kind of changes refers to the other, let's say, dbus interfaces which have to be implemented, and there's just another event on which the Orca listens and provides the feedback to the user. Okay.
Left alt, range values frame, entry. Backspace.
Okay, so
3D applet Boolean boundaries frame.
Okay, so another useful feature is in fact that by the dbus the whole application tree is exposed. So we can not only read just the button which is currently activated, but we can the whole subtrees we can use. So for example, let's say Orca introduced something like let's say call it accessibility focus, that it is not connected with the input focus of the widget or the window, but it's just some virtual pointer which are measured. So basically,
check toggle.
we can
task switcher, phone, message, GLU simple, GLU many gears.
We can read the application by not changing the input focus, which in some cases does matter for users with disabilities. As I said,
EVS map 3D GLU gears, GLU many gears, GLU simple.
What is more, we can read the UI directly by lines.
Message, phone, task switcher, check toggle, bubble separator.
Okay, so
app free entry.
One thing I want to show you is this kind of
scroll text frame, label push button, return.
This kind of feature saves
left alt tab, window, always show, slider 11 point.
I have, okay, so
image.
Okay, so basically there is always problem with not focusable components on the UI, but making this exposed hierarchy, we can easily use this let's say, virtual focus
This is a
to
larger label with
navigate through the UI without...
It won't expand or wrap, just be a block of text. This is more text designed to line wrap here as this object is resized horizontally. As it is resized, this small label set to wrap.
Okay, so it's is really useful for UI. Then developer don't have to, or framework don't have to adjust to the
text frame. Label push button, entry.
And there is
backspace, L.
Okay, so I would like to... The last thing I want to show is that...
divider frame, drag frame, type CND push, edge external frame, X scroller push, effect,
okay, so we...
focus, general, geographic frame, map push button.
So let's think about this way. So now the user has scrolled down, and we are using the accessibility focus to
scaling to focus on part, focus style,
to navigate
to focus free multi-button, entry and transit for animation, flip search menu, blank,
and we can
we
can trigger to each widget to activate. So what have I done just is that I practically change the way of navigating through this application, because in other way the user have to scroll all around top to get to this entry button, the entry field. Okay, so okay. Okay, so the almost last thing I want to share is that the work is still ongoing. Let's say the core part is done. However, there's an issue with the Elm object items, which is currently, I think, Jack Daniels is working on it, because from accessibility point of view, the Elm object items should be normally accessible widgets. But in fact, in elementary, there are not the EO widgets. But there is he has almost completed his refactor, and I have based my development branch on this. And I think to the end of October, the work will be finished. Okay, so another issue which arises that when I have introduced the AT-SPI API, we have found two accessibility APIs in elementary. So I would like to also discuss today about possibility to merge these two APIs and to provide one unified interface for the application developer. And generally, if I suspect that other parts in the documentation and bug fixings will take place, will be finished till March. So 114. Yeah, 114. Okay, so so one thing, one very important thing, that if you so the security issue which arises, because as you may have noticed, this whole accessibility stack, because I was using the keyboard on the elementary application, and in fact the Orca was was grabbing this key. It's done this way because it's worked this way that every keyboard touch is redirected to the accessibility bus, because I think there's no other way to do it currently. And there are a lot of exploits which were made at top of the accessibility. And here, if there's a link above to the interesting article about the exploits, it concerns iOS, Android, but in Tizen, for example, it can be made by implementing very strict dbus policies on the bus. And in this way, we can filter all the communication between the applications. Okay, so thank you very much. Any questions?
Yes.
Yes?
Is it possible to change the language?
Yes, it's possible.
And on which way I can?
It's you have to go to the Orca settings and then change the language.
Yes, but I cannot make my own language. Or is it possible?
Your own language?
Yes. The micro. I say that's.
I think it's not possible to, but maybe if there is a need for such feature, someone could do it. Yeah, because Elfish, I don't know.
I think you want to speak his own phoneme and let the voice.
That's various different language levels. Do you want the labels to contain your language? Do you want the speech engine to interpret text in with the phonetics of your favorite language? Do you wish, for example, Orca can say push button to say the equivalent in whichever language you choose, because there's certain text that's provided by it, there's text provided by the application,
Okay,
and then there's interpretation of that text phonetically.
Okay, so
Which one?
Okay. The interpreters. I think on navigation systems, I can change is it a girl or a boy? Is it here possible?
Oh, that's awkward.
Oh, that's Orca's problem. It's a good that. You'll have to ask the Orca devs. And actually, they're going to use what's the speech engine? eSpeak.
It's eSpeak, yeah.
And
It's
eSpeak does have
by
some
default, but you can install other, so it's not a problem. Okay, so any other questions? Okay, so thank you very much.